Hi to all, welcome to my third class on mensuration. In this class I am going to discuss area of general quadrilateral, area of rhombus and area of a polygon. Here you have a quadrilateral ABCD. You have to find out the area of this quadrilateral. You know, if B is the base and H is the height of a triangle, area of the triangle is equal to half into B into H. In this quadrilateral, if I draw a diagonal, this quadrilateral divided into two parts. Now, to find out the area of this quadrilateral, you have to find out sum of the areas of triangle ADC and triangle ABC. Let the length of AC is equal to D and the altitude drawn from D to AC, that is height of triangle ADC, is equal to H1, and the same altitude from B to AC we can take it as H2. Now area of triangle ABCD we can write it as area of triangle ADC plus area of triangle ABC. Here area of triangle ADC equal to half into base into altitude means half into AC into H1. So we can write which is equal to half into AC is equal to D and altitude is equal to H1. So half into D into H1 plus area of triangle ABC, similarly same base AC and altitude H2. So that you can write it as plus half into D into H2. Here you can see this half D is common in both. So half D you can take it as common. So we can write which is equal to half into D half D. Here H1 is remaining, here H2 is remaining. So we can write it as half D into H1 plus H2. This is the formula to find out area of a quadrilateral when two altitudes and one diagonal is given. Now let us find out the formula of area of rhombus. Formula to find out area of rhombus. You may remember the properties of a rhombus. Here you can see the diagonals makes an angle 90 degree. And the length of the diagonals, let us see, here it is 5, here also 5. That means just half of the length. Similarly here it is 4 and here it is. So we can say diagonals bisect each other at right angles. Here you have a rhombus ABCD. Here AC and DB are the diagonals. Let the length of this diagonals be D1 and D2. Let both the diagonals intersect at K. Now area of rhombus ABCD is equal to area of triangle ABC plus area of triangle ACD. How will you find out area of triangle ABC? Area of triangle ABC is equal to half into AC into BK. So we can write half into AC into BK plus what is area of triangle ADC? Here base is AC and altitude is DK. So that you can write it as half into AC into DK. Now what is the length BK? BK, you know, this BD is equal to D2. Then BK you can write it as half of D2 because diagonals of a rhombus bisect each other. And AC, the length you can write it as D1. So we can write half AC into BK, you can write it as half into AC is equal to D1 into BK is equal to D2. Then half AC into DK you can write it as plus half into D2 into D1 into D2 by 2. Now you can see half D1 is common in both. So you can take half D1 out. Or we can take here half D1 into D2 by 2. Here also half D1 into D2 by 2. The two half D1 into D2 by 2 are there. So instead of adding these two, just multiply 2 into 1 by 2 D1 into D2 by 2. Then we can write it is which is equal to 2 into half into D1 into D2 by 2. Here this 2 and 2 can be cancelled. So what is remaining? Half into D1 into D2. So area of the rhombus ABCD we can write it as half D1 into D2. You can write it as D1 D2. So area of a rhombus is half D1 D2, where D1 and D2 are the diagonals of the rhombus. Now let us discuss to find out how to find out the area of a polygon. Here you have a pentagon. How to find out the area of this pentagon? Here we can divide this pentagon into different parts. Now let me divide in this way. Now area of this pentagon is equal to sum of the areas of these three triangles. Then how will you find it out? For that you need the length of the altitude and length of this diagonal. Similarly, for the other triangle also, the altitude and length of the diagonal should be given. Here also, altitude and diagonal, if the diagonals are given, you can find out area of this pentagon is equal to sum of the areas of these three triangles. The same you can find out in another way. That is, if let me draw a diagonal here and the perpendicular distance. Here you can see this pentagon now divided into 4 parts. Here the area of this pentagon you can find it out by area of one triangle, and next area of this we can call it as a trapezium, then area of the one more triangle, then area of this big triangle. Now if the required measurement given, you can find it out the area of the pentagon by adding all these areas. By using all these formulas, you have exercise 11.2 questions. Do yourself. That is all for today's class. Have a nice day.